We are looking at the software configuration management, and if I can just name it as change management, that would be equivalent. But software configuration management is an umbrella activity which is very important. It's a project management activity. It goes right from the day or word go till the point that software is alive. The software configuration management is very important. Birsoff, he addressed that the first law, no matter where you are in the system life cycle, the system will change, and the desire to change, it will persist throughout the life cycle. And there are so many things which have been said about change. Change is the only static thing. Change is the only thing which never changes, and change is never ending. All these things are there because changes. Time is there, value is there, situation is there, everything changes. So software configuration management equally applies these changes to the software development. The output of the software process is information. We can divide it into three broad categories. In software we have computer programs. They may be source codes or executable form. Then we have certain work products that describe your computer's programs, like those which are targeted or valued upon the various stakeholders. Then we have data and content. Now these are contained maybe within the program or maybe placed somewhere else. So the items that comprise all information produced as part of the software process, they are collectively called the software configuration. Let me again tell you that the items that comprise all information produced as a part of the software are collectively called as software configuration. May it be the code, may it be the document, may it be the data, all those aspects, it's all the deliverables which are with the software, they are software configuration. So as software engineering progresses, the hierarchy or the various levels of software configuration items, we call them SCIs. So a named element of information that can be as small as a single UML diagram or as large as the complete design document by itself, which is created. So these software configuration items or SCIs simply lead to another SCIs, and little confusion would take place. Unfortunately, another variable enters the process, that is the change. So change may occur at any time for any reason or without any reason. So the first law of system engineering, it states that no matter where you are in the system life cycle, the system will change, and the desire to change, it will persist throughout the life cycle. And there is again a law that everyone resists the change. But change needs to be welcome, needs to be addressed, need to be managed. In software configuration management scenario, a typical CM operation, CM is configuration management. So a typical CM operational scenario involves a project manager who is in charge of the software group, the configuration manager who is in charge of the CM procedures and policies, and the software engineers who are responsible for developing and maintaining the software product, and the customer who of course uses this product. So in this scenario, just assume that the product is small, one involving say around 15k or 15,000 line of codes, which are developed by say a team of 6 people. And just note that the other scenarios of smaller or large teams are possible, but in a sense there are generic issues that each of these projects may face or may be concerned about configuration management. So in the element wise, if we want to talk about the SCM, Susan Dart, in her comprehensive white paper on SCM, she identified 4 important elements that should exist when a configuration management system is developed. First is your component elements, process elements, construction elements, human elements. Component elements, these are a set of tools that are coupled with file management system, for example, a database, you can say, that enables access to and management of each software configuration item or SCI. The process elements, these are the collection of procedures and tasks that define an effective approach to change management or the related activity to SCM for all the constituencies involved in the management, engineering, and use of computer software. Then the construction elements. These are a set of tools that automate the construction of software by ensuring that the proper value of validated components, means the corrected versions, we have assembled them. Then the human element, of course, we, the people. So to implement this SCM effectively, software team will employ a certain set of tools or process features encompassing other CM elements also. So these are the 4 important elements that Susan Dart, that she said in configuration management should be there. Component element, process element, construction element, and human element. So what are these changes? Because as I said, if I name SCM as change management, it makes a difference. So first we have changes in the business requirements, maybe certain changes in the technical requirement, changes in the user perceptions, requirements, say perception or intentions, or because of some pressure, market pressure, any other pressure. So we have these software models. We need to understand that the project plan, it had something already there. On the basis of that, it was being passed. We have tested them already. We have code, we have data belonging to our software, and there are certain other documents. But the changes could be, can be, will be affecting any of these. So in software configuration management, SCM, or in the 2 words software configuration, apart from the word that is called the code, we have programs, we have data, we have documents. We add them up and we say, this is our software configuration, and we need to manage them. So the baseline is, in IEEE, we define the baselines. What are these baselines? Because these are important as far as SCM is concerned. A specification or a product that has been formally reviewed, agreed upon, that thereafter serve as the basis of software development, further development, and that can be changed only through formal change control procedures. Talk about SRS. Understand about the high-level design. Say we have made a quality plan. These are all baselines because they followed a procedure. Now you follow a procedure to change them if you want. So this baseline is a milestone in the development of software that is marked by the delivery of 1 or more software configuration items and the approval of these SCIs that is obtained through a formal technical review. So these are the baseline structure. You have software engineering task. And as I said, that baselines, your SRS, your design document, your source code, your test plans, your procedures, your operational systems, these are baselines. So first of all, the software engineering task. For this, we need some modified SCIs and then certain formal technical reviews. If it is approved, then we store it. Extracted SCM controls are noted down. So for changing the baseline, there has to be a formal procedure, and we'll follow that. We need to follow that. And these are our baselines, which are the milestones. So the software configuration objects, it can be, software configuration or changes can be in design specification, test specification, data model, even in the components or the source code. These are the objects where software configuration needs to be addressed. The repository of SCM, like a library, you have books. In SCM repository, we have program, data, documents. So the SCM repository is a set of mechanisms and data structure that allow a software team to manage change in an effective manner. And the repository performs or precipitates certain functions. What are these functions of this repository? Data integrity, information sharing, tool integration, data integration, methodology enforcement, document standardization. So the repository has certain content, may be business content, model content, construction content, project management content, documents, and V&V, validation, verification content. Just take one example. I'll take one example. Let us take the, say, model content. So in model content, what our repository is going to have? It can have the use cases. It can have the analysis and design model. It can even have the technical matrix. And in this analysis model, it can have scenario-based diagram, flow-oriented diagrams, class-based diagram, behavior diagram. In the design model, we can have architectural diagram, interface diagram, and component level diagrams. This is the repository content we need to have, or we can have. So there are various features by which this software configuration management is being identified. First, we have versioning. Means we save all these versions to enable the effective management of product releases and to permit developers to go back to previous versions. We have version 1, version 1.1, and now we are at version 8.2. So all these versions before that, they are kept and properly managed. The dependency tracking and change management. The repository manages a wide variety of relationship among the data elements which are stored in it. The requirement tracing, that is, we provide the ability to track all the design and construction components and deliverables that result from a specific requirement specification. So let us have SRS. Now I need to know that I have a design document. This design document corresponds to which SRS. Now I have certain code. This code corresponds to which design and in turn to which SRS. This is requirement tracing. Then the configuration management. We want to keep track of a series of configuration representing the specific project milestones or product releases. Version management, this provide needed versions. And link management, keep the track of the interdependencies also. And of course the audits. Audit trails, that is, we establish additional information about when, why, and by whom the changes were made. So the process of software configuration management, it addresses certain questions. How does a software team identify the discrete element of software configuration? How does an organization manage the various existing versions of a program and also the related documents in a manner that will enable change to be accommodated swiftly, easily, effectively, and efficiently? So how does an organization control changes before and after software is released to the customer? Before the release and after the release. So who has responsibility of approving and ranking changes? How can we ensure the changes have been made properly as per certain guidelines or agreed upon, standards? So what mechanism is used to praise others of changes that are made? So these are the layers of SCM processes. These are software configuration items. Need to identify them: change control, version control, configuration auditing, reporting. So in all, SCM is a bundle of this activity. Let's start with the version control. So the version control combines procedures and tools to manage different versions of configuration objects that are created during the software process. As I said, we start with version 1.1, now we are at version 8.2. So the version control system implements and is directly integrated with 4 major capabilities. A project database, where we have the relevant configuration objects. A version management, it has the capability that stores all the version of the configuration object, whether it be of any version, and it also constructed using different past versions. The make facility, that enables the software engineer to collect all relevant configuration of objects and construct a specific version of the software, make facility. Then the bug tracking or the issues tracking capability that enables the team to record and track the status of all outstanding issues associated with each configuration objects. So these are the aspects of version control. In change control, since the reality of change control in modern software engineering contracts has been summed by James in his observation that change control is vital, but the forces that make it necessary also make it annoying. So we need to worry about changes because a tiny perturbation or some say not very systematic things, a tiny perturbation or movement in the code can create a very big failure in the project. But it can also fix a big failure or enable different wonderful new capabilities. So we worry about change because a single rogue developer could sink the project, yet brilliant ideas originate in the mind of those rogues, and a burdensome change control process would effectively discourage them from doing creative work. Change control, we need to stop. We need to change. So we need to see that whether we want a change or not. So there is a change control. We need to control the changes. So let us see the process of change control. Say a need for the change is recognized. We receive a change request from the user. The developer would evaluate. The change report is generated, and the change control authority, they decide whether we have to deny the change request or we have to queue it for the further action. If it is denied, we just inform to the user. Otherwise, we go to the change control process. So we assign people to SCI, check out SCI, make the change, review and audit the change, and then establish a baseline for testing. Then perform the software quality assurance and testing activities, check in the change software configuration items. We promote SCI for inclusion in next release. We rebuild the appropriate version, we review and audit the change, we include all the changes in the release. This is how we perform the changes or change management. So software configuration audit is important. It complements the technical review by assessing a configuration object for the characteristics that are generally not considered during the review. In review, we try to find out because it is formal technical review. We are interested upon the technical part, but the audit task can answer the following questions of software configuration. Has the change specified in the say any meeting or the request have been made? Any additional modifications been incorporated? Has a technical review been conducted to assess the technical correctness? Has the software process been followed and have software engineering standards been properly applied? Has the change been highlighted in the SCI? Have the change date and change author been specified? Do the attributes of the configuration of object reflect the change? And have SCM procedures for noting the change, recording it, and reporting it being followed? And have all the related SCIs been properly updated? So we need to audit the whatever we have done. We have to not audit it for a review so that the betterment can be done. So we have SCIs, the change request, and SQA plan. We'll audit for all these. The status auditing is also known as status counting. That we need to find out the accounts or account for all the change reports, changes which has occurred. In web, it becomes very important that because it has a distinct distinction between the conventional and object-oriented stuff. So we need to be very organized in terms of web because web is not very organized. So the content, the SCM for content, a typical web app contains a vast array of content which have text, graphics, applets, script, audio, video, forms, active page elements, tables, streaming data, and many others. So what is the challenge? The challenge is to organize this sea of content or the ocean of content into a rational set of configuration objects and then establish appropriate configuration control mechanism for these objects. The people, because a significant percentage of web app development continues to be conducted always in an ad hoc manner, evolutionary manner. So any person involved in the web app could create a content. Scalability. As size and complexity grows, the small changes can have a far-reaching and some maybe problematic or unintended effects. Therefore, the rigor or the intent of configuration control mechanism should be directly proportional to the application scale. The politics. Who is owning a web app? Who assumes the responsibility for accuracy of the information on the website? Who assures that the quality control processes have been followed before information is published on the site? Who is responsible for making changes? Who assumes the cost of change? So the content management in web app configuration management. The collection system. The collection system encompasses all actions required to create or acquire content and the technical functions that are necessary to convert content into a form that can be represented by a markup language, or organize content into packets that can be displayed efficiently or effectively on the client side. Then the management system, the collection system and the management system in the content management. So it implements a repository that would encompass certain things, as we already said, content database capability, and configuration management functions. Then the publishing system. We need to extract from the repository, convert it to a form that is amenable or acceptable to the publication, and the formats it so that it can be transmitted to the client-side browser. The publishing subsystem can accomplish these tasks during a series of templates. And each template is a function that builds its publication using one of the three components: static elements, publication services, or external services. These are very important as compared to the content management system. So we have a client-side browser in the web app. These are the database and the templates on the back side, on the server side. Now, where are our configuration objects? Where are they? This content management system, we have all the HTML codes and script. We need to place this content management system so that we can just make the content or the configuration better. So to implement effective change management within the code and go philosophy that dominates the web app development, the conventional change control process can be modified. Each change could be categorized into certain categories. Class 1 is the content or function change that corrects an error or enhances the local content or functionality. The content or function change that has an impact on other content objects or functional components. A content or a function change that has a broad impact across a web and major, say, extension of functionality, significant enhancement, reduction in the content, major required changes in navigation. Then the major change. We started with the smallest one. We have reached to the major one. Change in the interface design, navigation approach that will immediately noticeable to one or more categories of users. So to manage for web apps, we need to classify request change as we just saw. Change 1, change 2, change 3, change 4. Change 1, okay, is the least effective or least weighted. Change 4 is highest rated. So change 1, okay, let us see whether it is okay to make change. We don't have to go through all these. We have to start from here. Just go to this point and check out object to be changed, make changes, design, construct, test, check in the object that were changed and publish to the web app. What about class 2 change? We acquire related objects and assess impact of change. If changes are required in related objects, otherwise we do the same stuff. Check out the object to be changed, make changes to design, construction and test, check in object that were changed and publish to web app. Then the 3. We develop a brief written description of change, transmit all team members for review. Okay, not okay. Or say further evaluation may be required. Class 4. We develop a brief written description of the change, transmit all those stakeholders for review. Then further evaluation may be required, otherwise okay. So these are the way in which we want to change or we want to manage the change in the web app. So this was about the SCM or software configuration management. Thank you so much. Take care.